Hi, this is a live stream I'm doing for an astrophotography guide video, the first episode, where I show people how to process Milky Way images that they've captured using their phone. I've got Serial open now, and let me show you exactly what I'm going to be doing. Now, the original video goes over things very quickly. I'm going to try to go over things step by step. So the first thing that you want to do once you've downloaded Serial, if this is the first time using Serial, is to kind of get familiar with the interface. So we have some buttons up top here. This is an open button. This lets you open up any file. This is the home button. The home button lets you set a working directory. So if I click on this home button, then it lets me set a working directory where I've got all of my files in it. So here are my light files. These are all of the files I took taking pictures of the Milky Way while I was in backyard the second night I was imaging. These are all the flat frames that I took, and then there are the dark frames that I took. So the home directory. So if we go back to the home directory, all the files that Serial is going to create, and Serial is going to create a lot of files, are going to be put into this home directory. So if we wanted to, we could make a new folder and call it something like Serial processing, but I'm just going to leave it here for now. Another thing about the home directory is if you were trying to open a file, so if we want to open a file, then it automatically opens up into the home directory, which is kind of nice. So the first thing that we want to do is we want to convert all of our files into what are called sequences. So we want to take our dark files, convert it to a sequence, and then stack them to create a master dark file. Then we want to take our flat files, create a sequence of flat files, and then stack them to create a master flat file. Then we want to take our light frames, we want to create a sequence. We want to take our master dark and our master flats that we created, and then calibrate each of our light frames using them. After that, we stack those frames. Before we stack them, we have to register all of the light frames that have been calibrated, and then we can stack them. So let's go ahead and we will start with our dark file. So I'm going to press this plus button right here. So just highlight it a little bit. Here's the plus button. And then this will open up our home directory, and let's choose our dark files and add them. Now, all of our dark files are here. I only have, 8 dark files. Should have probably done more, but that's okay. And I'm going to change this sequence name to darks. So right here. So we changed it here. And then we're going to click on convert. It says a file name darks already exists. Do you want to replace it? I've already done this once. So yes, we do want to replace the file. Okay. And it's going to open up in the sequence tab. It's created a dark sequence for us. We can open up the frame list in order to check each of the dark files that it's made. So what it's done is it's converted all of those DNG files, which are raw files. They're raw Samsung. Well, they're just raw files. DNG files are a type of raw files that Samsung uses, and has converted them to fit files. And if we want to, they're very dark, and they should be dark because I took those files with the lens covered with tinfoil. Sorry, my brain is taking a while to process things. So it's covered with tinfoil, put it over the phone, and I took a series of frames with no light hitting on it. And if we go to the auto stretch here, we can see that this is what the dark frame looks like. If we zoom in, we can see some pixels are kind of always brighter than other pixels. So if we go to this, here are all of the dark frames that I took. And if we look here, we can see that this pixel right here is a hot pixel. It's always a little bit too turned on, basically. And if we were going to stack all of our light frames without having a dark frame calibrated out, then this hot pixel would show up. So what we want to do is use these dark frames to tell Serial, hey, this is a hot pixel. We want to correct for that in the final image, and it will correct for it, which is nice. So we've got all of these fit files that Serial has created. It's converted the DNG files to fit files, and it hasn't gotten rid of those DNG files. It's just created new ones. So if I go into the working directory, you can see all of these dark fit files that have been created. Go into the darks folder. These are all still here. So it's just created new fit files. It's created a sequence of dark fit files that it will use, and then we can just go ahead and stack them. Now, there is a tutorial on Serial that tells us how we want to stack each type of image. So if we go to this page here, we go. So we go to this page here, it tells us everything we need to do for manual stacking in Serial. So we're not using any scripts, we're just doing everything manually. So we don't have biases, we don't have dark lat, because we didn't talk about dark lat. So what we need to do is just look at the darks, and this tells us what we want to do when we're stacking dark. So it says average stacking with rejection and no normalization. And then all of these other parameters just tell it sort of how it should be rejecting some of the bad pixels. And then we can go ahead and do start stacking. So let's go ahead and do this. We'll go to the stacking tab here. We'll have average stacking with rejection, and we're going to do no normalization, and everything else seems correct. And we're just going to go ahead and do start stacking. I was going to stack stack all of those images and create a master dark for us. So yeah, here we go. It's already loaded the master dark. We can tell because this name here says dark stacked. So it took whatever our sequence name was, which was darks, and put an underscore and a stack on it. Okay, let's see here. All right, we want to do the same thing with our flat files. So let's go ahead and remove all of these dark files from all of the source list. So I'm going to go ahead and you can just select them all and then click minus, or you can just use this button to remove all the files from the list. So let's go ahead here. We'll call this new sequence flats, and we will add our flats to it. So we'll press this button again, and we go to the flats folder, and we select all of these, and we add them. Once they're added, we can click convert. Oh, yes, I've already stacked these before. There's already an existing file called flats in the, whatever memory Cyril has. So I'm going to go ahead and replace that. You don't have to deal with that when you do this. So then we can look at the sequence, and we can look at all of our flat files. So we can open this frame list and just take a look at their flat files to make sure they're okay. And I already checked these. These are fine. You don't really have to check the flat files, of course. It's just something that you can do. And of course, now in our sequence selection, we have a dark sequence and a flat sequence. And whatever we choose here determines everything else that goes on in the other tabs. So if we choose the dark sequence and we go to stacking, it's going to stack the darks again. So we want to make sure that the flats are selected. We go to stacking. We go here. We go to Cyril's page. We can double check everything. We don't have the calibrator flats. We just have to create a master flats. If we had dark flats, then we could calibrate everything. But since we don't have dark flats, we just want to kind of start stacking. So average stacking with a rejection, and then multiplicative normalization. And let's go to the stacking tab here. So we have average stacking with a rejection. That's good. And then multiplicative for rejection. And we have 10 images in our sequence list. So we're going to go and start stacking those two. So it has stacked all of them. And then it has given us an output called flat stacked, which is good. And what we want to do now is we can already go to this calibration tab, and let's uncheck these. Okay, we can go to the calibration tab, and the use dark, use flat is selected. I don't know if this automatically puts in what was just done, but it might be blank for you. There might not be anything in here. So if it says use dark and use flat, and it doesn't have any file name in this box here for the dark file, we want to click on this button to open up the folder, and we would go to our home directory, and we will find the dark stack file. So remember, everything that Cyril does, it puts in our home directory. So we have all the darks is converted to fit files, plus the stack dark files. So we've got to find the darks underscore stack.fit file, open it to tell Cyril this is where our dark file is. Then we do the same thing with our flat. So we go ahead and do this because we've stacked the flat already. It should be in our home directory. So here is our home directory. It says flats underscore stack.fit, and we want to open that. Now we are ready to pre-process our lights. So before we pre-process anything, we want to open our lights and convert all of the lights into a sequence. So let's go into our lights folder. We'll scroll all the way down to try and get all of our lights selected, and we will add them to the source box here. We will change the sequence name to lights and then do convert. Again, because I've already stacked this, it's asking if I want to overwrite the existing file. Of course, for this demo, I will be. So it's converting all of these into bits files. And if we open up our folder, our home directory, you can find it here. This is our home directory, and it's starting to create all of these fits files for us, which is fine. We actually don't need any of these files. We don't really need any of these files. So after we're done stacking, we can just delete everything. But we won't delete everything now. Okay, so we have all of our lights. We go to sequence, make sure that we have a new sequence, which is called lights underscore dot sequence. And we can take a look at them by clicking on this button here, down here, where it says linear. Let's change this to auto stretch. So this is what one of the images looks like. It looks pretty nice. I kind of like it. It's not pre-processed, so there are probably some hot pixels in here. There's vignetting in the corners. So the corners are darker than the center of the image. And so what we want to do is go ahead and pre-process these images. So we make sure that the light sequence is selected. We go to calibration, and we can do start calibration. Now what it's going to do is going to create a new sequence. The new sequence is going to be whatever our sequence name is now, which is lights.sequence, with a prefix of pre-processing underscore. Instead of pre-processing, it's just PP. Let's go ahead and do start calibration. It's going to take our master dark and our master flat, and it's going to correct each of those light frames. So if we go back to our folder here, there's a lot of work being done in the background. There's like a couple of hundred images. And so we're getting new fits files for each of our light files. So we have a pre-processed light file, each of our files now. Hopefully that makes sense. And again, these images, you can, when you're done stacking and done doing everything, except for all of the stacked images, which you want to keep, you can delete everything else. So I'm going to go ahead and minimize this. And now we have processed sequence here. So if we look at the sequence, now we have the pre-processed sequence, and we can open the frame list to take a look at everything. And here are all of our images. Now, these first two images were just images that I used to kind of frame the Milky Way to get it how I wanted to. So I took this image, I looked at it, and I wasn't satisfied. I moved the phone a little bit down. I thought, oh, I moved it the wrong way. So I went, oh, I guess I didn't move it the wrong way. I guess I wanted more trees in the image for some reason, which I don't know. I was weird. But I don't want these first two images in my final stack of images because they're not quite lined up with the other images. So I'm going to go ahead and deselect these. And once we deselect them, there'll be this X. The X means that it's not going to go into our final stack. Okay. Now we can go ahead and look at these and make sure that they all look okay. When I was taking the image, or when I was taking these images in Pennsylvania, there was like a floodlight that had that was motion activated, and it was motion activated. And so I think bugs were flying in front of it and turning it on and off all night, which was kind of annoying. That makes the image worse because every time that light is on, a lot of the detail here gets kind of washed away. But we want to find a nice image where we can select, some stars. So we want to go somewhere in the middle of the stack and make a selection here. And this box will be used to register all of the light frames. So every time I take an image, right, the Milky Way moves just a little bit. So you can see the stars moving across the image as I scroll down and select different images. So these stars are here now, and now they're up here. So like what we need to do is line up all of the stars as best we can. And Cyril does that for us. So let's go ahead and find one that's in the middle. Okay. And we can use this one as our reference image. So all of the other images in the stack will be compared to this image, and Cyril will try to stack them based on where the stars are in this image. And not all of the images might not be stacked because it's such a wide field and it's just a cell phone. Sometimes Cyril will fail at trying to align them, and it's okay. We'll just get as much as we can because we're not tracking. The stars are moving, pretty fast across the frame. We're not doing any stacking. It's harder for Cyril to actually line up the images, so we might lose a few frames. It's just what happens when you don't have a tracking mouse. Let's go ahead and I'm going to close this. We're going to go to the registration tab now and make sure that global star alignment or deep sky is checked. And then we want to make sure that this match stars in selection is checked. Now, all of these other parameters, you can just leave them as they are. So it's going to try and find 10 matching pairs of stars in each frame. And if it can't, it's going to skip that frame. The maximum number of stars it will look for, 2,000 pairs. We probably don't need that many. It's probably overkill, but it's just what it is. We can also change the settings here if we want to. If it's not finding stars, we can change some of these parameters to have it find more stars. But if we go ahead and click on this button, it's going to try and find all the stars in this selection. It's found, I don't know, quite a few. So it's found 132 stars. Hopefully it'll be able to find a similar number of stars in the other FITS files and other calibrated files. So we go ahead and close this. The prefix is going to be R underscore. So whatever the sequence name we have now, which is PP underscore lights underscore sequence, is now going to have an R in front of it. The new one is going to have an R in front. So we're going to go ahead and register all of these frames. And this will take a few minutes to do. So it's matching stars. Every time it matches, it'll have a green text that says, oh, it's matched it. Sometimes it won't be able to find some stars and it'll just skip it. So I'm thinking that we will probably, out of the 200 or so images that I took, we might only get like 150 or something, maybe less. So go ahead and wait until this finishes. Okay, we actually got 206 images registered. One image failed. Hopefully that's correct. That's good. So let's go to the sequence tab. Now we have a new sequence with R underscore PP underscore lights. Let's open the frame list and see what we've got. You can see that now the images are kind of in color. So before Cyril was processing black and white images, and now it's processing them in color. It just does that once it's registered. So let's just check these and make sure that they're actually okay. Sometimes stacking goes a little bit weird and you get kind of weird like things going on, but it looks like things are okay. You can see that the trees are moving, but the stars are staying put. That's exactly what we want. Okay, so you see that the trees moved, the stars are in the same place. So if we zoom in, these stars every time I click on a new image should remain in the same spot. Good, that's good. Okay, so hopefully if all of these actually, were registered correctly, once we stack them, they should be fine. Let's see here. Yeah, so you can see that this one was probably towards the end of the imaging session where the stars here are gone. And so it's moved everything. Oh, let me back up. The Milky Way has rotated across the sky, right? And so now we are looking at a different, subsection of the sky than we were before. So the trade-off when you don't have a tracking mount is, of course, you don't get get, you don't get to use the whole part of your sensor. Your sensor is effectively being cropped as everything is being, as everything is being registered and all the files are being lined up with each other. So all of these files are being lined up. Let's go ahead. I'm going to close this and we're going to go to stacking. And now we want to make sure that in our stacking tab, because now we've calibrated the images. Let's see, we've aligned the image. Now we want to stack. So let's go average stacking with rejection, and then normalization is additive with scaling with these parameters. And let's go ahead and make sure that these are checked, which is force 32-bit output, RGB equalization, and output normalization. We will go ahead and make sure all of those are checked. Additive with scaling, output normalization, RGB equalization, and force 32-bit output. And we'll go and start stacking. And this should take, depending on your computer, a couple minutes. Depends on how many files you have as well. Down here, I don't know if you can see this, there is a progress bar. So as the little blue line goes up, it shows you the progress at each stage. So right now it's computing the normalization of each frame. So it's trying to normalize the different color channels and the brightness. And then it will start maybe doing a different thing, and then it will start stacking. Okay, it's now stacking using there it is. We've got the final stacked image. Everything looks good. The stars look nice and round. I mean, as round as they can be. And then the trees look like they're blurred, which is expected. So let's go ahead and go to image processing. I want to make the image stand like right side up, the trees pointing upwards. So image processing. We will go to geometry and rotate 90 degrees clockwise. All right. Okay. So I'm glad that so many images stacked this time. Sometimes it's hit or miss, but because so many images stacked, we do kind of get these aberrations on the sides because, a cell phone lens isn't exactly perfect. I'm fine with that as long as these stars in the middle are okay. Okay. So my computer is being very slow right now. Now, the first thing that we want to do, probably as I did in the video, I'm going to turn this into linear mode, go to image processing, and then stretches, and then histogram transformation. A little thing will pop up, and I'm just going to click this button right here. Right here, I don't know if you can see where my mouse is. This is the auto stretch button, and it auto stretches it just like it did before. I'm going to click apply, and then I'm going to download it I'm going to save this file as the foreground. And it really doesn't matter what I save it as. It would be like a PNG or a JPEG because the foreground isn't as important. I'm going to save it as a PNG file just in case. That's going to save. Okay, now I'm going to undo the auto stretch because I don't want it, but I'm going to turn on the auto stretch preview down here. Okay, so it hasn't stretched anything. What I want to do is remove sort of the gradients using the background extraction tool in Serial. So I'm going to go to image processing here, find background extraction. Let's see. Okay, so I went to background extraction. It popped up on my other screen. I wasn't able to see it. So now RBF is fine. I feel it does really good. It does a really pretty generally good job at doing a background extraction. And then I'm going to turn the smoothing slider all the way up and make sure add dither is checked because it doesn't hurt for it to be on. And I'm just going to click around random points on the image, maybe like 10 or 15 points. Just click, making sure I'm not getting any of the bright areas of the Milky Way or any bright stars. And I'm going to click compute background. And once I do that, and there we go, everything kind of pops a little bit more. The color has changed a little bit. That's fine. I'm going to go ahead and maybe add one more point here and do it again. Try it again, see if it changes anything. It doesn't really. And then we can play with the smoothing slider here. It's just this kind of controls how aggressive the background extraction is. Lower is kind of more aggressive. You can have each of these points matters more. Just compute background a little bit again, and then things didn't really change. So I'm going to click apply. I feel like I've got too many programs open. And compute background has gotten rid of a lot of the gradients, has brought out a lot of the little bit more detail in the Milky Way, I think. I'm going to click apply, and then I'm going to turn off this auto stretch. I'm going to turn it back to linear, and we're going to actually do a real auto stretch with stretches, histogram transformation. It'll warn us that some pixel values are outside the range. I'm just going to have to go and clip it for now, and then press again this auto stretch button here. It stretches it so everything looks like it did before. We click apply, and now these changes have been kind of saved to the image. We can always undo them if we need to, but let's go ahead and save this as we'll call it the Milky Way background image, and I'll save it as a TIFF file. It's going to be saved as a 32-bit TIFF file. You can see that up here. Go ahead and save it, and then save. Once that's been saved, I'm just going to go and close Serial. It's taking a while to save, I think. There we go. Once that's been saved, I'm going to go close Serial, and then I'm going to take this let's see, we've got the foreground, we've got the Milky Way background, we've got the foreground, we've got the stacked bits file. All these other files we really don't need anymore. So we could just go through and delete them if I want to. I'll delete them later. But let's go and open up this TIFF file. I'll right click it, and I have GIMP. So I'm going to go ahead and open with GIMP. And then I'll open up the foreground as a new layer. Okay, let's go ahead and open up as a new layer. So open as layers, file, and open as layers. And then we will find the foreground and open that one. It'll ask us if it wants to keep the color profile that it has. We do. So we'll go ahead and keep that. And we can see that the foreground, the trees look better, but the Milky Way looks worse. So there's less detail in the Milky Way. So I'm going to go ahead and right click on this foreground image. I'm going to find add layer mask, and I'm going to check white for full opacity. Now what that's done is create a layer mask anywhere that's associated with this layer, this foreground layer. Anywhere there is white on this layer mask is where this foreground layer shines through. Anywhere there is going to be black is where it's going to be transparent. And so what we want to do is make the Milky Way part of this image transparent. So I'm going to take the scissors tool. So the scissors tool is here. You can see that. I'm going to click on it. I'm just going to zoom in. I'm going to start clicking around this image to make a selection that doesn't include the trees. Don't have to be perfect. We want to be kind of just good enough, basically. Okay. And then we'll connect them by clicking on this one, and then pressing enter, and we have a selection. Okay. Now making sure that the layer mask is selected and not the layer itself. So we look here, this means that the layer is selected because there's a white outline around the layer. We want to select the layer mask right here. We'll take the bucket tool, find the bucket tool right here. This will fill up everything that we tell it to fill up. So we're taking the bucket tool, we're going to do fill whole selection and click on the sky. And once we do that, you can see that the layer mask here, part of it has turned black, which means it's now the black part of this image is now transparent. We can press Control-Shift-A to select everything. And then we've got some funky stuff, right? Like it's very abrupt where the layer mask, where the trees are, right? It's very abrupt, like the color change between the foreground and the background. So we can take this layer mask, make sure it's selected, go to Filters, Blur, and then Gaussian Blur, and move this slider up. Once we move this slider up, it's going to blur this mask itself, and see it starting to blur, make things blur in better. We click OK, and now that's better, but it's not quite perfect. So I'm going to take a paintbrush here, the paintbrush tool, and then I'm going to make sure that the hardness and force are kind of low. I'm going to start painting in first around the edges. Brought some of the other trees back in from the Milky Way, which I kind of don't want. All right, and with that, I think we've got basically a finished image. You can keep iterating with the layer masks and the different layers, changing the foreground and changing the background and making things less saturated or more saturated, and bringing out the color or whatever. So again, I'm just taking this, making the trees foreground come in, be a little bit more prominent, because I want this desaturated. And you can keep messing with this, changing things up however you like to. We could add another Gaussian blur to the layer mask. So make sure the layer mask is selected, then go to Filters and Filters, Blur, and Gaussian Blur. And then we can move these sliders up and then click OK. And then again, you can keep iterating, changing the colors of the foreground and the background separately. And then when you're done, you can export this as whatever file you want. So you can go to File, Export As. And then if we wanted to export that as, this is just like a JPEG, we could do that. We could do Milky Way finished. And once we do that, it's going to ask us how much we want to compress the JPEG. And we can go ahead and say 100% or whatever, and then just export it. And it should be in the folder, whatever folder we saved it in. All right, I think that's it. This is just a quick tutorial to help, supplement what was shown in the video. Again, you can change the colors. You can do whatever you want to in GIMP or Photoshop. Thanks for watching.